Welcome everyone to our first Women in 3D Printing Youth Wing webinar. Today's panelist is Jo Sommers. Jo Sommers is the Women in 3D Printing Sydney Ambassador. She's the co-founder of MakerSense, a platform for education that includes 3D design curriculum. She's been in the 3D printing industry for 6 years, and before that was the creative director at global advertising agencies in LA, London, and Sydney. Welcome, Jo.
Hi. Thanks for having me.
So let's begin with a few questions. So you were a creative person all your life, and you have had experience with different companies in advertising. It seems like your creative edge took you to additive manufacturing. Can you share your journey into 3D printing briefly? Were there any specific events or opportunities that sparked your interest in the subject?
Sure. So I was living in LA and I took part in a startup weekend, hackathon, I guess you could call it, LA Startup Weekend. And I met some really inspiring people that were into building apps, and very rarely were people building hardware because it's so hard. But I went to Silicon Beach Fest and was part of the audience watching people pitch their ideas. And the finalists, there were 9 app ideas being pitched and 1 hardware, and that piece of hardware was AIO Robotics, the all-in-one Zeus printer, which is a scanner and printer all in one, the world's first. And I was blown away, and so were the judges, because they won first prize. And I went and met the inventors of the brilliant device after the show to congratulate them. And we got talking, and I realized that maybe there's an opportunity to work with them. And they said they were looking for a marketing creative person to get their story out there. So I joined them pretty much the next day, and we did some really fun stuff together. I helped them with their Maker Fair, where we worked really hard to build an amazing booth with a lot of it. It was probably one of the biggest Maker Fairs in the world at the time. This was probably 5 years ago, and that really launched the product. And we got a lot of great PR out of that. And then we went on to do other events together, such as the Los Angeles Special Olympics, World Games, where we used Enable's brilliant open source design of prosthetics and worked with Google and did an event there. So my big inspiration, seeing the machine, was thinking about all the applications for 3D printing, which includes prosthetics, and for us, the obvious place to focus was education. So meeting them and seeing the amazing opportunities that were on the horizon for this great technology was really inspiring. And that really launched my passion and my interest in dedicating myself and throwing myself full time into exploring the exciting world of 3D printing.
And how did you think of the idea of your book?
So when we carved a line in the sand, looked at all the different ways that 3D printers could be used, from industry, product design, in manufacturing and fashion industry, architecture and everything, we realized that education was the place to focus, but there was very little in the way of curriculum to help teachers really meaningfully, purposefully integrate it into their curriculum without it just being another piece of technology that sort of sits in the corner and intimidates people. So this is the promise, right? So in the classroom, theoretically, you could have biology students studying cross sections of organs, which 3D printing enables beautifully. I mean, you can do that without 3D printing. There's a lot of models that schools have already, but 3D printing allows you to print deeper and richer and more less expensive models for biology students to understand anatomy. Same with chemistry, obviously, and engineering with cars and geography. And there isn't a subject really that couldn't benefit from 3D printing. In theory, history classes, you can 3D print artifacts to study fossils or architecture, design. That was the promise, and that's in theory. But in reality, as we all know, this is what happens quite often. And so classrooms are left with 3D printers that sit in the corner because everybody's too frustrated by them. A lot of them don't work as they should, or they work for a while and they don't sustain for very long because you need to maintain them. They're very intense, high maintenance. Most of the inexpensive machines that are under $2,000 take a lot of technical knowledge and trial and error. So we basically thought there really needs to be a really easy place for people to start, so people aren't turned off by the failures that happen in when you start a new technology and start a new learning curve. So we really wrote a manual and a book that we wished we had when we got started, because I've got bags and bags. I've kept all my mistakes and the failures and the prints that failed as just to showcase that it is actually valuable. It's important to fail. A lot of people say fail fast, break things. That's how you learn. But you also learn by doing and by not being frustrated. And we didn't want to turn too many people off with, showcasing too much of the failures, but to show people how they can be successful and just things to watch out for. But what we really wanted to write the book, we really were inspired by 3D design, and Tinkercad actually is a brilliant place for people to start, and for people not to think about 3D printing as something where you need to operate a machine. We wanted people to think about 3D printing as a place to start getting more creative and to focus on design, not the output. And I use the analogy to people with, if you study photography, you're studying the composition and the lighting, and you're thinking creatively about what you're capturing in that camera. And then you just assume that photo will print if it's not going to just live on screen. If you want to actually print it out on a printer, you're not thinking about how that printer really works unless that's your focus. If your focus is on photography, you're not really thinking about the output. And the same goes with 3D printing. I think the big focus should be on the creative process and not the output. And I think that's where everybody gets hung up, and I get teachers especially who are so time poor and stretched in all directions get sort of turned off about how important it really is to use 3D printing as a tool in the classroom, that it's creating more headaches than positive outcomes. So we wanted to show focus on the positive outcomes, and also explain that really with Tinkercad, you can just get started right away. You don't need to think about the output, because there's so many wonderful services where you can outsource to. So you can send your print away and get it sent back. And that's really what is the big value of the 3D printing in the classroom, is the creative process and the design, not the actual maintaining of, for a school to really successfully do 3D printing and to satisfy all the kids' needs, the demand, keep up with the demand, you need to have your own print farm on site, and that's not feasible for a lot of schools. So outsourcing is really a great way for schools to encourage the 3D design and 3D printing process without having to deal with all the hurdles and the stumbling blocks. So I also like to say to people, you don't teach pens, you teach writing. So we want people to focus on 3D design, not 3D printing, and that's why we wrote the book, is to really explain that and to say, look, there's so many different outputs, and the technology is always going to change throughout the years. It's already changed so much. There's lots of different ways to output, and only one way to design, and that's with your brain and creative thinking. That's never going to go away, not tomorrow anyway, in terms of how fast technology is moving. The creative and critical thinking aspect is always going to be the key to all of this, and to future sustainability for positive workforce placements for today's students. So here in our book, we focus on explaining that, and this is all the different types of 3D printing. There's 7 main ones that are quite complicated to understand, and none of these are really feasible for schools except for the material extrusion, which is also called FFF or FDM, and that's using PLA, which is a corn-based plastic that is known as the green plastic, and it's cost effective and it's the safest way for schools to get involved and to have most of those desktop 3D printers actually use material extrusion. So it's a good place to start. But understanding the landscape and all the different types of additive manufacturing machines is really important. And we wanted to communicate that in a really easy to understand and fun way to read.
And do you think do you feel that additive manufacturing should be mainstreamed into schools and colleges? I know I do because from what I learned about it, I felt that there's so much to do with technology that students can benefit from and specialize in now.
Absolutely. So, additive manufacturing is the future. As I said before, creative and critical thinking is key. There are loads of opportunities for 3D printing in the future for pretty much every single career you can think of. It's going to have an additive manufacturing element to it in some form. And I really think that it teaches the modern way. The 4 C's of education is the 21st century classroom. We want to focus on creativity, communication, collaboration, and critical thinking. So we do think that additive manufacturing is the future, and it's important for people to understand the context and the bigger context, the role it's going to play. It might not impact every person directly. They might not all want to be designers or engineers and might want to go into other aspects, but understanding, even as a consumer, how things are going to be made in the future and how things are going to be sustainably made in the future is really important in fitting in with these 4 C's of education. And that's why this is so key to STEM curriculum and education in general.
And are there any suggestions that you have to bring about a change in discussing 3D printing?
Yeah, so I think people need to focus on the design process, as I said before, and that mainly we need to outsource for volume output. So if you think about a class of even 20 to 30 kids, which most classes are about that size, and each student does a design project, say a balloon car or a box or something that's roughly 4 or 5 inches in width and height, that print is going to take probably anywhere between 3 to 8 hours on one printer. And if you times that by between 20 and 30, that is way more hours than is feasible and way more hours than one teacher and one printer can handle. So that being said, I think outsourcing for volume output is key, and also to change people's perceptions. And also, a lot of people get hung up on the fact that we're making more plastic, and a lot of people say that as their big reason for why they're not excited about 3D printing. It's just more plastic junk that we're making and putting out there into the environment. And I say that people need to look at the bigger picture and what it means. It's additive manufacturing taking over subtractive manufacturing, where in the long term we're going to be consuming a lot less plastic and a lot less material. We're going to have less carbon emissions because we're not shipping items, because of localized on-demand manufacturing enables us to make things more locally across the globe. And we're storing less things, so we don't need to power big warehouses with lots of air conditioning. That's a big contributor to global warming. And also landfill is also a big contributor to global warming when big piles of junk are polluting the environment. We can reduce that by having less stuff and only making stuff we need, and also using recycled materials and natural materials that can biodegrade more effectively, and also a reduction of recycling and reducing material waste by recycling PET bottles and other materials like that. There's a lot of advancements happening in 3D printing materials at the moment that I've seen people print with everything from clay to sawdust. There's a company here in Australia that's using sawdust that's swept up from the floor of furniture warehouses and stuff like that to blend it together to make a filament that then 3D prints furniture made out of sawdust waste. So there's a lot of different ways that in the long term it is environmentally friendly, and that is really important for people to understand the bigger picture of the benefits rather than the short term, you know, the short term impracticalities of more plastic junk. It's really about opening up all those possibilities for long term sustainable manufacturing. And I think that starts with kids as young as 8, 9, 10 in the classroom to think about that and to think about future careers in that, and getting involved with high level mathematics and science to make all that happen and make all that a possibility in their future to contribute to society.
Well, thank you so much for joining us today, Jo, and for discussing your journey through 3D printing.
Thank you so much. I've loved our chat, and I think you're doing wonderful work being the future of additive manufacturing, and I believe you're going to do something in the medical field with it, and I think that is just very exciting, and I really am so glad that we've crossed paths, and I hope we can stay in touch. Thank you so much.